Welcome all, welcome to this lecture of object-oriented programming. Today we will see unit 12, the last unit of this syllabus, that is concurrency. Let me show the disclaimer, then I'll start the session. Okay, so concurrency is provided by threads. In Java, thread states and lifecycle provide concurrency. And so we'll see thread states and lifecycle, then we'll see thread synchronization, and we'll see how we can create and execute threads using the executor framework. Okay. So check this out. The what are thread states and life cycles? In Java, what happens is Java supports multi-threading. So Java can create multi-threaded programs. It can extend the idea of multitasking by taking it one level lower. That each task basically usually is called a thread. So what can happen is each task, and the threads are lightweight as compared to processes. So if you are comparing multi-processing, the multi-processing is heavier and multi-threading is lighter. So programs that can run more than one thread are called as multi-threaded programs. And there are 6 states of a particular thread. So the starting state is the new state. From the new state, it goes to the runnable state. Okay, from new state it goes to the runnable state. Now from runnable, it can go to a block state. It can go to a block state, right? It can even go to waiting state. And it can go to timed waiting, and then it can go to terminated state. From lock it might get terminated, or from waiting it might get terminated, or from runnable it might get terminated. From waiting it can again go back, as it from runnable it went to waiting. In the same way, from waiting it can go to runnable. From blocked, what happens is from blocked it goes to waiting first, and then it goes to runnable. From blocked it does not directly go back to runnable. Understand? That's what happens. So these are some of the 6. These are the 6 states which are basically. These are the 6 states that basically. These are the 6 states. These are the 6 states that represent the thread states. Okay. So check this out. Here is the actual diagram. From new, it can go to runnable. When does it go to runnable? When we call the start method of the thread. Okay. From runnable, it can go to terminated. It can get terminated. Okay. So when the run method exits, at that time also it gets terminated. It's not like terminating is interrupting. It ends. It can, when it ends, it gets terminated. As simple as that. Now from runnable, it can go to the block state. When it needs to acquire a lock on a particular object. Once the lock is acquired, until the lock is acquired, it goes into the block state. Once lock is acquired, it comes into runnable state. Waiting, it might not yet have got the some resource, so it can wait. And once the notification comes for that, it can again go to runnable state. And there is time waiting. When there is time specified that this much time you have to wait. Once the timeout happens, it goes back to runnable. See, so runnable is the main in middle point. Okay, this is new diagram because previously there was not this time waiting. Now this time waiting has also come in threads. So new state is when a thread is in the new state just created, right? And the program, it has not yet started executing the code. It may be something like that. Runnable state is when you invoke the start method, the thread comes into runnable state. So it means it has started executing the code now. Understand? So once a thread is running, it doesn't necessarily keep running. When the slice of time is exhausted, the operating system preempts the thread, that is, takes the thread and gives another thread the opportunity to work. So another thread is allocated the resource. Okay. So runnable state for a thread is there for some time only. Again, it comes back. So from runnable, where does it go? It may go to blocked or waiting state. If it is waiting for an input out some IO device, then it goes into block mode. If it is waiting for its turn for the processing, it goes into the waiting state. The thread is blocked or is waiting, it is temporarily inactive. It doesn't execute any code and consumes minimal resources. Memory is not used so much and all those things happen. Processing also is not done. So it is up to the thread scheduler to reactivate it. And this thread scheduler is handled by JVM. In the end is the terminated threads. So either you exit the thread normally or you exit the thread by uncaught exception. And you can even kill the thread using a specific method. And there are various methods of thread. Join is the method which waits for specified thread to terminate and then join for processing. Join with milliseconds waits for specified thread to die or for the specified number of milliseconds to pass. Then comes get state. It will give you the state of the thread. Let's get the state of the thread, and it can be new, runnable, blocked, waiting, timed waiting, or terminated. Now these came from Java 5. Okay, this came after Java 5. These states were not there before Java 5. It stops the thread, but this method is deprecated, not allowed to be used. Understand? Suspend is also that, but this method is also deprecated. Resume is there, which resumes the thread which had been waiting. But this is valid only after, this method is only valid after suspend has been invoked. So if you had invoked suspend, then only you can resume it. And this is also again deprecated. So it's not recommended to use. Deprecated means it is not recommended to use. Now let's see what is thread synchronization. So in multi-threaded applications, 2 or more threads need to share access to the same data. So what happens if 2 threads have access to the same object and each calls a method that modifies the state of the object, right? That you have to imagine what happens. Okay. And that is not predictable, that's the main thing. So the Java language provides a synchronized keyword for protecting a code block from concurrent access. And the synchronized keyword automatically provides a lock. So method is declared with synchronized keyword, the object's lock protects the entire method. Okay. And so depending on the order in which the data were accessed, corrupted objects can result. So such a situation is called as a race condition, when two threads have access to the same object and each calls a method that modifies the state of the object. So it can create a corrupted object. Okay. What you do is, with your method that you are going to access with the thread, you make it synchronized. So only one thread at a time can enter this method. As simple as that. Other threads will have to wait until and unless that thread executes and completes this particular method. Now there is notify all, which unblocks the threads that called wait on this particular object, and this method can only call from a synchronized method or block. And this method throws an illegal monitor state exception if the current thread is not the owner of the object's lock. There is notify method also, which unblocks one randomly selected thread among the threads that called wait on that particular object. Okay. And this can also be called within a synchronized method or block only. Similarly, there is wait method. So see, wait method makes the thread wait. Notify method notifies that particular thread that now it does not have to wait. Notify all notifies all the methods that were waiting for a particular object to acquire its lock. Okay. Wait causes a thread to wait until it is notified, and this method can only be called from within a synchronized method. And there are other methods also: wait with long milliseconds, wait with milliseconds and nanos. Okay. So, these are threads. Okay. Now there is something called as executor framework. Okay. So server programs such as database and web servers repeatedly execute requests from multiple clients, and these are oriented around processing a large number of short tasks. So in server application, it creates a new thread each time a request arrives and serves this new request in the newly created thread. So what happens is, it's something like this. There is a client. Okay, there is a client side, then there is a server. Request comes from a client. Now there is a resource that needs to be run. Let's say this is a kind of Sowlet page. Let's call it as a login page. Right. Let's say this is client 1, and then there is a client 2 also. The client 2 is also requesting to the server. So what happens is, at a single time, both the requests come, but both the requests come in the form of a different thread. So there is one thread passing for client 1, another thread passing for client 2 from this code. At the same time, this code is executed for two different clients. Okay, that is multitasking or multi-threading. So what happens is, the disadvantage over here is the server that creates a new thread for every request would spend more time and consume more system resources in creating and destroying the threads. So as active thread consumes system resources, JVM creating too many threads at the same time can cause the system to run out of memory, and this necessitates the need to limit the number of threads being created, and that's why the solution is thread pool. System can have thread pool. The thread pool reuses previously created threads to execute current tasks and offers a solution to the problem of thread cycle overhead and resource thrashing. So since the thread is already existing when the request arrives, the delay introduced by the thread creation is eliminated and makes application more responsive. So now Java provides something called as executor framework, okay, which is centered around the is centered around the executor interface. It's which is a sub interface. Okay, and executor, it's like sub interface dash executor service. Okay, and the class is thread pool executor, which implements both of these interfaces. Now, by using this executor, one only has to implement the runnable objects and send them to the executor to execute. So to use thread pools, we first create the object of executor service and pass a set of tasks to it. The thread pool executor class allows to set the core and maximum pool size, and the runnables are run by the particular thread and executed sequentially. So here is the thread pool. These are threads which are maybe idle or using. And these are some tasks which are waiting in a queue for the thread. Okay. There are methods like new fixed thread pool, which creates a fixed size thread pool. This thread pool is created. New cache thread pool, which creates a thread pool that creates a new thread as needed, but will reuse previously constructed threads when they are available. New single thread executor creates a single thread only. So java.util.concurrent.executors, this is the class that came, this API came since Java 5.0. Okay, it was not there before. So one of the main advantages of using this approach is when you want to process 100 requests at a time, but do not want to create 100 threads for the same. So, and you do not want to overload JVM. At that time, executive framework is very, very important. You can use this approach to create a thread pool of 10 threads, and then you can submit 100 requests to this thread pool, which will reuse all the 10 threads one by one. And the thread pool will create a maximum of 10 threads to process 10 requests at a time. And after process completion of a single thread, thread pool will internally allocate the 11th request to this thread and will keep on doing the same to all the remaining requests. So this executor service is a class, okay, which has got methods like submit, the runnable task, shutdown. This submits the given task for execution. This shuts down the service completing the already submitted task but not accepting new submissions. Then there is this thread pool executor, where you get the largest pool size. It returns the largest size of the thread pool during the life of this executor. So this is some theory about it. Let's see some programs now. So this is about threads, right? So what we will do is we will first see how to create threads. So to create threads, there are two ways in which you can create threads. The first is you can either implement runnable, which is interface. Okay. So take this code. Here thread01 creation class implements runnable. It means this class, the objects of this class are now runnable objects. What is runnable? What is it? This interface it should be implemented by class whose instances are intended to be executed by a thread. So if you want that the threads should be accessed by the objects of this class, then you can make that particular class as runnable. This class must define a method of no arguments, having no arguments, which is called as a run. Okay. So what happens is, check this out. Here we have this run method, which we have implemented, which we got from runnable. We say that the thread is running. Okay. And here also we say that the main thread is running. Why I say main thread? Let me show you. When you say Java and thread 01 creation, when you run this command onto the command line, what happens is this Java command creates a thread which passes through this class. And where does it enter? What is the entry point? Entry point is this main method. So in order to execute this main method, a thread is created. Let's call it as a main thread. Let's call it as what? Main thread. Okay. The main thread will execute all this code. So first we have thread 01 creation. We create one object of this class itself. Then we say thread T1 is equal to new thread M1. So we pass this object. This runnable object is being passed. Why is it this runnable object? Because that class implements runnable, right? So we pass that runnable object to this thread, to this new thread class, in order to the constructor of the thread class, in order to create a thread object called as T1. Now there is T1 thread also. There are two now threads, which there is one main thread, okay, and the another thread is this T1, which basically starts executing when we call this T1.start. So what happens is, up to this much part the main thread executes. As soon as it sees T1.start, as soon as it sees this, what happens is one thread gets created. This T1 thread gets created, and the control goes to the run method, and it executes there. And this also keeps on executing. This also keeps on executing. As simple as that. Okay. So now what happens is the main thread is also running and the T1 thread is also running. This thread is running over here. T1 thread. T1 thread is running over here. Understand? So both may run simultaneously. So we cannot guarantee which output, this output or this output, which output might come first. We cannot guarantee that. Let me show you. Let me run it out. Here it says the main thread is running, the thread is running. Okay. We'll call it as what? We'll say the T1 thread is running. Okay. Let's run this. Main thread is running, T1 is running. You see that? So currently the main thread is running, is coming first. That's fine. But there are situations where this main thread is running may come afterwards also. Okay. You can see here T1.start directly send the control to this run method, but this executed first and then this executed. Sometimes this may get executed first and then this would get executed first. That might also happen. Okay. So how does that happen? Check this out. So there is another way also of creation of class. So for example, here we say thread 02 creation extends thread. Now this is another way. Either you implement runnable and you implement this run method, or you extend thread class and you override that run method from coming from that thread class. So these are the two ways in which we can make our own thread objects. Understand? Through this you implement runnable and implement run method, and then you create an object of that thread and give it to new thread constructor in order to create a thread object. Here you will not, here we will require only one step. Here you needed to create a new object and then pass it to the thread. But here what happens is the object itself extends thread. So you need to create only one object because it will have its own run method. So you say thread creation, thread 0 to creation, T1 is equal to new thread 0 to creation. So here you create two thread objects. What do? Here you create two thread objects. Then check this out. We have this name which belongs to this thread to 0 to creation class, which is nothing but a what? An instance variable. So T1 has its own instance variable name, T2 has its own instance variable name. One is A, one is B. T1's name is A, T2's name is B. Now we call T1 and T2. We start executing T1 and T2 by calling it start method. So what happens is, currently there are three threads going on. Which one enters over here? The main thread enters over here, right? Up to this part there is only main thread. As soon as these two execute, it starts two thread. One is the T1 thread and another is the T2 thread. So T1 thread also goes to this particular method and T2 thread also goes to this particular method. So both the thread are trying to access the same method. Which method? The run method. But both are different threads, so that's okay, there is no issue in that. So what happens is, here we have in this run method, we have this for loop where we start printing from 1 to 4 or 1 to 5. That's as simple as that. Let's print it as 1 to 5. So what happens is, here we print the name, colon, and then the iteration number, the loop iteration number. So it would print A colon 1, A colon 2, A colon 3 in such way, right? If it is thread 1. If it is thread 2, it would say print, it will print B colon 1, B colon 2, B colon 3 in that way, right? But we don't know what will be the sequence because both are threads and we cannot even predict it. Let's see that. See, here the sequence comes something like this. A1, B1, then A thread gets more chance, so A2, A3. Then B thread gets more chance, so B2, B3. Then again A thread gets more chance. Again B thread gets more chance. You see that? It can go up to 3 or 4 times also. It's not that only 2 chances are there. If you simply increase this, instead of 5, we call it as 50. And then we run it. We'll come to see that at various places, see, at this place, the B has got a lot of chance. B executed a lot of times. You see that? So this behavior is not predictable. This shows that the thread behavior is not at all predictable. You cannot predict the thread behavior. You cannot say if that you started two threads A and B, then it would go in the same sequence only, like this. A, B, see here B comes 2 times and then A starts. Again B, again A, again B, but B comes 2 times. You see that? It might happen A also might get some more chance sometimes. Here see, check this out. A is getting so much of chance. See that? Because B has finished first. Right? So you can see, you can understand how the threads work. Okay. The only thing is, here we are extending this class. We are extending thread class. This class is extending the thread class. So what happens is, you just need to create the object of that thread. That's it, that class. You don't need to pass it to thread, or you don't need to do runnable or something. Understand? Because it has got the run method. Now if we see, there is something called as this sleep and wake and all those things, right? So we can make this thread go to sleep. We can make the thread go to sleep. How? By this way. Check this out. This in this class we extend thread. Then we say public void run, and inside this run we have some code like we run the loop for I is equal to 1 to I less than 5. Okay. Then we say inside this for loop, we said try, inside this try we said thread dot sleep. So the thread goes for sleep for some 800 milliseconds, and then it will again continue. So if at all any interruption comes, then it might throw interrupted exception, which will be printed out. And if that thread dot sleep has finished, then the control will come over here. Control comes over here in this location and prints the value of that I, that is that iteration. So you will see that this method, when this method executes, it takes some time and slowly execute. So what we are doing is we are creating the two objects of this thread type, and we call t1.start and t2.start on each, and we run. Check this out, it is coming slowly, right? 1 1 2 2 3 3 4 4 5 5. In this way it is coming. You can even give some name to this thread object by saying, putting here over here as string name is equal to empty string, and here we will give the names. What? t1 dot name is equal to 1, and similarly t2 dot name is equal to t2, and this name would be used to print over here. We can say name, attach with it psi value, as simple as that. Now if we run this, check this out, first T2 started executing, then T1, you see that? And if we change this, we change this sleep duration to 1000, let's say it becomes 1000 milliseconds. So if I run, it waits for a second and then displays, you see that? First it waits, so as soon as the control comes over here in this run method and it goes into the for loop, first it waits for 1000 milliseconds and then it executes this part. Got the point? So that's why the output is coming very, very slowly. This 1, this 2, this 3, this 4, and this 5th iteration. In this way it comes, you see? And there is no sequence guaranteed. Here T1 comes first, then T2, then T2 comes, then T1 comes 2 times, then T2 comes 2 times, T1 comes 1 time, T2 comes 1 time, again T1 comes 1 time. You see that? So there is no specific sequence that in which it will get executed. Okay. So this particular was an example of sleep method. Now sleep method can throw an interrupted exception, right? An interrupted exception. So we are putting that in try catch. Sleep method call. You cannot use sleep method call directly without using try catch or without declaring as throws. So that is about sleep method. Now let's see one more example. That is about test synchronization. What does this test synchronization do? Check this out. Here we have a table class which has got print table method where you pass some n. Now see, this method is not synchronized. So if any thread passes through it, if multiple threads passes through it, then there will be a different kind of output, you know. Here we say that for loop starts from 1 to 5, and we print this n into I. What is this n? The n, that is the number that was passed. So we print its value, right? Because we have to print a table. We can even print it like this. What? N concat with multiplication operation, concat with I, again concat with equal to, again concat with n into I. This will look like a good, what? Good table. Okay. Now this is table class. Okay. Now we say my thread 1 extends thread, and inside that my thread 1 constructor we pass the table object, which is assigned to this t, instance variable of this my thread 1. And inside run, what do? We say t dot print table 5. So we send this value to this tables print table method. Okay, and it prints the table accordingly. So this is my thread 1. Then there is my thread 2, which extends thread. See, here also this my thread 1 extended thread, which in run method, it called this t dot method, which is not synchronized method. In my thread 2, we have this, again we have this table, which is being passed over here into this my thread 2 constructor, and it's associated with this p. And then here what we do, here also we say, here we run, here we have inside this run method, we say t dot print table 100. Okay, once we are saying t dot print table 5, then we are saying t dot print table 100. Now we say test synchronization. Inside this test synchronization example, what we will have is we create a table object, only one table object, and we pass that table object to both the threads. So the single object is being shared by two different threads. Now T1 dot start and T2 dot start. So what happens is two object is that is specifically the table object. Okay, that is a table object. So that table object is being passed to this my thread 1 and also to this my thread 2, and in one run method it prints the tables of table of 5. And another run method prints a table of 100, table k, again for some time 5 table k. You see that? So that is what is happening over here. Okay. And now if you have a common variable inside this table class, int suppose is there, okay, which starts with value 1. Then we don't declare the I is already declared, right? So what we do is, okay, we make it up to 10, not 5, 10. Okay. Now this I is common, is that between both the T1 T2 threads. So what happens is one thread may increment I, so other thread will see that effect. Okay, so in this case, let me run the, see, check this out here. What happens is, this is, we made it as n into I, right? So n is 5, but the I is 1 here, then I is again 1 over here. Then see, 2 got away, God knows where did it go. So here it came directly 100 into 3. Then a 5 into 3 also, 2 went away for that also, you see. So then came 4, For 100 into 4, then came 5. Since the 6 went away, 7 is there, 8 is there, and 10, 9 went away, and 10 came directly. You see that? So what happens is, it might have happened that one particular method would have incremented, this particular thread would have incremented 8 to 9, and this particular thread would have then incremented that 9 to 10 automatically. So you can see after this directly 10 comes, not 9 does not come. You see that? So that's the problem. Understand? When we use an instance variable, inside a loop that is basically executed by multiple threads, that becomes a problem. And if it is synchronized, suppose we make this method as synchronized. Okay. Suppose you make it as synchronized. So now what happens? Let's see. Run this. So see, at a time only 5 stable comes, and since I value has gone to up to 10, so there is no way that the tens the hundred actually hundreds table come. So what we will do is, instead we will remove this int I equal to 1 from here, and we'll again put it into this for loop, inner for loop, right? Now we'll run this. Let's see. So the 100 table will also come, 5 table will also come, but any one table will come first. See that? It comes in sequence because we made the method synchronized. Understand? So that is threading. If we don't make a particular method synchronized, right, then multiple threads can pass through it. And if we make it synchronized, then only one thread can pass through it at a time. Okay. So that is about threads. It is about what? It is about threads. And that is concurrency. So any doubt in this threads, please do let me know. Abhishek is asking, what is the difference between try and catch? Okay, try is a block, Abhishek, where the try is the block where exception can occur. Understand? And it assures the JVM that the code that can throw the exception is put inside try catch block, so JVM can execute. So it provides that assurance to the compiler that the code which has the probability of throwing an exception is basically put inside try catch block. Understand? And we are using it to handle the exception. I think you are not there while handling exceptions. So that's why you don't know why we are using it. We are using it so that exceptions can be handled, and if any methods are throwing any particular particularly throwing any any exception, then that can be handled. Okay, for example, check this out. For example, if I don't give this try catch block over here, if I just comment it out, so what happens is, see, this gives an error. What does this give? The thread, it says unhandled exception type, interrupted exception. So what happens is, the sleep method declares that it can throw an interrupted exception. Since it declares that it can throw it throws an interrupted exception, here we need to anyhow put try catch, or we need to declare over this run method that this run method throws an interrupted exception. And that is not allowed because the previous run method does not throw. That came from this thread class does not throw. So we cannot increase the scope of this run method by saying that all this throws, but the previous method that it overrides does not throw. That is not allowed in Java. So we put this thread.sleep inside try-catch so that that compiler error will go away and compiler allows us to run this particular code. Understand? So that's it about this thing. Okay, try-catch block is finished, and this. Okay, so our concurrency unit is almost finished. Any doubt in this unit? Please do let me know. Okay. I'll stop the recording and we can have interaction.